This is 4.4a radical expressions. Radical expressions involve when you're adding or subtracting radicals from one another or with just whole numbers. It involves multiplying radicals and taking them to a power. So there. So when you're adding radicals, you have to remember that you can only combine like terms. So in the case of square root of x plus square root of x, those are like terms. They're the exact same thing, so you get 2 square root of x. But if you're adding square root of x plus square root of y, those two are very different and they don't combine. So as far as you can go with that, as much as it can be simplified as what it's already written as. So that is the completely simplified form of square root of x plus square root of y. So when you're adding radicals, you have to remember, like I said, combining like terms. So you have 1 plus 2 here, you got 3. And square root of 2 plus square root of 2, that makes it 2 square root of 2. So that's as much as that can be simplified. So not every time are you going to end up with numbers or terms that can be combined. So you got 1 plus 3 again, you get 4. But square root of 3 plus square root of 2, the way I said it is as simplified as it's going to get. So 4 plus square root of 3 plus square root of 2 is a completely simplified radical expression. So combining like terms, you have to make sure it's addition first of all, and then you just combine them. So 5 plus 6, you get 11. So think of the square root of 2 almost as a unit. So you got 3 square root of 2 and 6 square root of 2. When you add those together, it's just 9 square root of 2. You can combine these because they're both carrying a unit of square root of 2. Subtracting radicals is really the exact same operation, just of course subtraction. So square root of x minus square root of x, it's like having a 1 here, so you're subtracting 1 unit of square root of x from another unit of square root of x, which makes 0. Although if you have square root of x minus square root of y, those are completely different terms and they can't be combined, so you are already left with a completely simplified radical expression. So in this case, of course, it's just still the process of combining like terms. You have 1 now minus 3, so negative 2. And you have negative 2 minus negative 2. So when you subtract a negative, you're really adding it. So if you distribute this negative 1, you now have a positive square root of 2. So negative square root of 2 plus square root of 2 is 0, so this is a completely simplified radical expression. So it's important to remember that these can cancel each other out just like any normal number. So in this case, you have 3 plus square root of 3 minus 5 plus square root of 3. So yet again, combining like terms, 3 minus 5 is negative 2. So now you distribute this negative 1, you got negative 3. So now you have positive square root of 3 minus square root of 3. So yet again, your answer is negative 2, and that is your absolutely, completely simplified radical expression. So you just have to remember simple addition and subtraction rules. So you combine your like terms, you get negative 1, and 3 square root of 2 minus a minus. So that makes this plus 6 square root of 2 3 square root of 2. Now you have 9 square root of 2. That's a completely simplified radical expression, and that's a time when this negative 1 here, when it distributes, that makes a positive. So this subtraction makes it a positive just due to simple addition and subtraction rules. So multiplying radicals follows just a slightly different set of rules. Now whatever's under the radical can be touched by whatever's underneath another radical. So you have square root of x times square root of x. That makes square root of x squared. The square root of x squared is just x, because you can simplify that by bringing out two x's, making it just x. But now you can also combine, through multiplication, different values underneath the radical. So now you could have, say, x and y underneath different radicals, and when they multiply, you can still put them underneath the same radical. So square root of x times square root of y equals square root of xy. So when we multiply this, we have to remember to distribute. So 5 times 6 is 30. 5 times negative 2 is negative 5 square root of 2. Square root of 3 times 6 is 6 square root of 3. And square root of 3 times negative square root of 2. Now you're going to get something different. You're going to get square root of 6. So we have no like terms to combine here. So that is the completely simplified radical expression. So we have to distribute. So we get 14 for that first number. Now you have 2 square roots of 2. Distribute this. You're going to get negative 7 square roots of 7. Now for this last part, negative square roots of 14. Now this is another situation in which none of this can be simplified any further, because if I was to prime factor all of these, those are completely prime, and then in this case both of those numbers are prime. So nothing here can be done to simplify it any further. My simplified radical expression is 14 plus 2 square root of 2 minus 7 square root of 7 minus 14. Now, in this situation, it will be simplified further. 3 times 5 is 15. 3 times square root of 2 is 3 square root of 2. Square root of 2 times 5 is 5 square root of 2. And square root of 2 times square root of 2 is square root of 4. And now, this is a situation where things are able to happen a little differently. Because now we have things under the radical that can be simplified further. When I prime factor that, I find a perfect square. So now what I have instead of square root of 4 is 2. And also, what I have here is these both carry the same unit, so they're like terms. So now what I can do is combine those. What I have there is 8 square root of 2. And what I observe is that now this is a plain whole number, so it can be combined with 15. It's 17 plus 8 square root of 2. That's my completely simplified radical expression. And then there's taking a radical to the power of something. So if I have the square root of x and I squared that, I simply get x. But I can also do this with whole expressions. So if I had 1 plus square root of x squared, it wouldn't just be applying this square to both of those. You would have to write it out next to it and distribute. So I get 1 times 1 is 1. 1 times square root of x is square root of x. And x times square root of 1, or square root of x times 1 is square root of x, and square root of x times square root of x is square root of x squared. So when I combine my like terms and simplify this, what I'm going to find is that I have a 1 plus now 2 square roots of x, and this can be simplified to bring out 2x's, so now I have plus x. That right there is how you simplify a radical expression when taken to a power. So in this example, or really all examples, I'm just going to write it out twice and follow distribution rules. So 3 times 3 is 9. 3 times negative square root of 5 is negative 3 square root of 5. Square root of 5, negative square root of 5 times 3 is negative 3 square root of 5. And square root of 5, negative square root of 5 times negative square root of 5 is positive square root of 25. So what we observe in this case is that we have like terms to combine and a perfect square underneath the radical to simplify. So now we can pull out a 5, and what we're going to have to do is combine our like terms. So we have negative 6 square root of 5, and we have a 5 over here to combine with this 9. And once we do that, 14 minus 6 square root of 5 is our completely simplified radical expression. It can also be taken to different powers, so all you have to do is follow exponential rules. Instead of just writing it out twice, I'm going to write it out 3 times. So the way you want to go about solving a problem like this is just double distribute your first two as you normally would. 5 times 5 is 25, and then you have negative 5 square root of 2. So you're going to get another set of that, negative 5 square root of 2, and you're going to get plus square root of 4 by distributing that. So once I simplify all this down, I'm going to have to bring out that 2 there. So I'm going to have 27 minus 10 square root of 2. So now I can multiply that by my final, and just double distribute again. I'm going to get 27 times 5, which is 135. I'm going to get 27 times negative square root of 2, that's negative 27 square root of 2. So then just double distribute this. I'm going to get negative 50 square root of 2 and distribute that. I'm going to get plus 10 square root of 4. So now that we have this, to completely simplify it, we just have to bring out our perfect squares. So when you bring out the 2 this time, you have to multiply it by that 10. So you're going to have 10 times 2, which is 20, plus now this right here. These can combine. So what we're going to get is negative 77 square root of 2 plus 20. And you still have this positive 135 here at the front. And what you got to do is just combine your like terms, and you get 155 minus 77 square root of 2. And that is your completely simplified radical expression. That's the end of that tutorial video. 4.4a radical expressions. Thank you for watching.